the second day of 7.3. Okay. So this is a hyperbola that we're going to graph where the center is not at 0, 0. Yeah, I would use graph paper. It will be a little helpful. Okay. So first of all, let's figure out whether it's horizontal or vertical. So which one is positive, the x or the y? The x. So it's horizontal. What is the center of this hyperbola? So center is h and k. So positive 2, positive 1. Okay? So 2, 1. I also want a and b. Okay, so what a squared is 9, so a is 3, and b would be 2. Okay, so a is always your horizontal distance, b is always your vertical distance. No matter if the hyperbola is horizontal or vertical, or which one's bigger, a is always horizontal and under x. Y is always vertical distance and under y. All right, so grab your center and let's graph the rectangle. So my center is 2, 1. I could go ahead from my center and do my transverse and conjugate axes. So that is part of this complete graph. So these are your transverse and conjugate axes. The horizontal lines are y equals, and it's the y coordinate of the center. Vertical lines are x equals, and it's the x coordinate of the center. Since this hyperbola is horizontal, then the horizontal axis is the transverse axis. Okay? And then this one is the conjugate.
We have to label the conjugate.
Yeah, you'll have to know which one is which. Okay, and then my rectangle, A is 3. So I'm going 3 units left and right. B is 2, so 2 units up and down. And then I'm sketching in that rectangle so that I can draw my asymptotes. Yes. Yes. Okay, so your asymptotes go through then the diagonals of your rectangle. So you can't draw the hyperbola until you have your asymptotes. Because you have to show that, it's between the lines. That's what it's approaching. We will talk about the equations of the asymptotes, but we'll wait to do that till the end. All right, so since this is a horizontal hyperbola, then the vertices are on the horizontal edges. I have vertices at -1, 1, and 1, 2, 3, 4, 5, 6, 6 points. 5, right? Actually, 1, 2, 3, 4, 5. Yeah, sorry, 5 lines. by 1. Okay, so go ahead and sketch in your hyperbola. Don't forget to do that part. Does the hyperbola actually go through the vertex? Yeah, it does. Okay. The last sign is to graph is the foci, and then we'll talk about the equations of our asymptotes. So foci. So for a hyperbola, it's a squared plus b squared equals c squared. So a squared is 9, b squared is 4. So that's 13. So square root of 13 is c. Okay, so that is between 3 and 4, 3.6. Okay, so from your center, you're going out 3.6 units. Okay, you need them graphed and labeled. So your labeling can be on your graph or it can be to the side. Okay, so you started from your center, which this was 2. Your x-coordinate was 2. And then you went right, square root of 13. And then you're still at 1 for your y-coordinate. And then from 2, you went left, so minus square root of 13. And again, you're still at 1. Okay, so our graph is pretty much done. The only thing that I haven't labeled are my asymptotes. Okay, so first of all, let's talk about the slope of the asymptote. So the slope is going to always be b over a and negative b over a. So like this one is b over a because slope is rise over run. You're counting. So we're counting from the center to the corner. So up to right 3. So that's y equals 2 over 3x. This time my y-intercept is not 0. They're not both 0. So I have to figure out where it crosses. So I'm looking at this one. So that crosses below 0. So I know I should get a negative y-intercept. So right now I'm just going to put plus b because I'm not sure what that y-intercept is. And this b stands for y-intercept, not the same b as our vertical distance. So,
well, is there an equation, or do you just like count left to right?
well, you can go backwards, but it's going to be between 0 and negative 1. So to figure this out, we have to calculate where that would happen. We have to plug in a point that I know is on the line and solve for b. Well, I know the center is on that line. So plug in the center for x and y. So the center is 2, 1. So 1 is y, 2 is x, and I'm solving for b. So I'm trying to figure out where that y-intercept is. So that's 4/3. And then if I subtract, I get negative 1/3. Equals b. So my equation is y equals 2/3 x minus 1/3. Okay, that's the equation of that asymptote. I have to do the same thing for the other asymptotes. There's the other asymptote. There are two asymptotes. So I'm looking at the bottom one here. So this slope is negative b over a because you're going from the center to the corner down to and right 3. So y equals negative 2/3 x plus b. It still goes through your center, so plug in Q1 again and solve for this y-intercept. So 1 equals negative 2/3 times 2 plus b. That's negative 4/3 plus b. So it should be 7/3. So that equation is y equals negative 2/3 x plus 7/3. And make sure that makes sense based on your graph. So does that look like that asymptote goes through the y-axis at about 2 1/3? Yeah. The second one, I got negative 1/3. Okay, that looks like the first asymptote goes through at negative 1/3. So that is the equation here for this. Okay, that is a complete graph. We have everything labeled and graphed. Okay. All right. So it gets a little bit harder when your center is not at 0, 0. Your transverse and conjugate axes are shifted, and then finding the y-intercept of your asymptotes, that can be a little tricky too. All right. The next thing we're going to talk about is the definition. Oh, nope. We'll do the definition in a minute. First thing is identify whether we have a circle, ellipse, or hyperbola, and then we'll write it in standard form. Right, we use the coefficients of x squared and y squared to tell whether it's a circle, ellipse, or hyperbola. All right, so the coefficient of x squared is what's the coefficient of x squared? 1. The coefficient of y squared is negative 4. So A and B, like capital A and B, so we're not confused with little a and b. Okay, well, are those numbers the same? No, so it's not a circle. Are their signs the same or opposite? Opposite, so it's a hyperbola. If the signs were the same, then it would have been an ellipse. Okay, then putting it in standard form is where we have to complete the square. So group your x's, group your y's, and move that plus 16, that constant, over to the right. Anything that you need to factor out for x? Nope, nothing to factor out for x. I'm still just putting it in parentheses so I show that that's a group. What about y? Yep, you need to pull out the negative 4. Take the negative with that 4. So that's y squared. So if I take out negative 4 from negative 16, I get plus 4. Y. Alright, so whatever number I have to add to complete the square for x, I don't have to multiply anything because I didn't factor anything out. Whatever I have to add for y, I have to multiply by negative 4 because I factored out that negative 4. Okay, so complete the square, b over 2 squared. Negative 12 over 2 squared is negative 6 squared, which gives us 36. So add 36 to the left and the right. Alright, complete the square for y. Just look at what's inside. So b is 4. So 4 divided by 2 is 2. 2 squared is 4. So you're adding 4 to the left. And on the right, you're adding negative 4 times 4. So which is actually negative 16. Okay, factor those now. So what do the x's factor to? X, good, minus 6 squared. And then the y's, I still have that minus 4 up front. And that factors to y plus 2 squared. And then equals 4. Negative 16 plus 36 minus 16 is 4. And what's the last step? Divide everything by 4 so you get an equals 1 on the right. Alright, so I got x minus 6 squared over 4. There was nothing to cancel. Minus, okay, the 4 over 4, those just cancel. So I have y plus 2 squared. I'm still going to keep that over 1, so I'm able to identify what b is. And 4 divided by 4 is 1. Questions about that process? That is something you will have to do on your quiz. Okay, now we're going to talk about the definition of a hyperbola. So this is a summary of what the definition says. So that's how we get a hyperbola. Is you start with the foci, so you start with your two fixed points, and then the difference of their distances, the set of those points, is a hyperbola. So with an ellipse, it was d1 plus d2 equals k. With a hyperbola, it's d1 minus d2 equals k. The k greater than 0 just means that you want it to be positive. So you will take the bigger one minus the smaller one if you're calculating that. Okay. So we want to use the definition of a hyperbola to find the distance between the vertices and the dimensions of this rectangle. So I want to talk about getting like the little shortcut formula like we did with the ellipse. So just like an ellipse, K is equal to 2B, or 2A if it's horizontal. This hyperbola is vertical, so K is equal to 2B. I will show you why that's true. You won't have to memorize or be able to show the proof of why that's true every time, but here's why. So it means any point on the hyperbola, the distance from that point to each focus, that difference is K. So I'm picking, let me be specific and pick this point, this vertex. Okay? So this is my XY. I'm going to call that my XY. So I know here's my center. So what I want to look at now is this as distance 2, because I want that to be smaller, and this as distance 1. Right? So the distances are the distance from the point to each focus. Okay, so distance 1 and distance 2. Okay. So I'm telling you that when I subtract D1 minus D2, I get K, which I'm telling you is 2B. And here's why. So your vertical distance from your center to the top of the rectangle, or in this case the vertex, is always B. So here to here is B. Here to here is B. Okay? The distance from the center to the foci is C. Okay, so here, this is C, this is C. So distance 1, so what I had here in red, here to here, okay? Well, that's C plus B, okay? C plus B. Distance 2, what I have just right here in blue, is C, so C minus B. Okay? So then if I said that K is distance 1 minus distance 2, so that's C plus B for distance 1 minus C minus B. Since I'm subtracting that whole thing, I have to have it in parentheses. So C plus B minus C plus B, if I distribute that negative, and I combine my like terms, my C's cancel, and I get 2B. So that is why that is true. Again, you will not have to show me that. You don't even really have to understand it. But I wanted to show you, in case some of you don't understand why that can happen, that's why. All right, so I know K equals 2B. Yeah. Let's do the very top bar right here.
So the green stuff I did that.
Okay, that's fine. Oh, okay. Okay, so I'm going to use this information information to actually work through a problem now. So this is what would be given to you. You'd be given these directions and you would be given the sketch. Just a little bit. So I'll give you a minute to get this written down before I start working through it. I'll go back. Okay, so I have to find K because I want to know B, right? I want to know the distance between the vertices. So I'm looking actually for this whole distance. So here's my center, and I want to find B. So that means I'm going to use that K equals 2B. I also need to use the definition, so I need to use that distance 1 minus distance 2 is K. All right, well, I can find distance 1 and distance 2 using distance formula since I have the ordered pairs. So distance 1, I'm going to do square root of -9 minus 0 squared plus 6.25 minus -13, so plus 13 squared. And I calculate what's underneath without doing square root yet. Just don't want to make any mistakes. So we should get 451.5625. Don't do any rounding because then when you square root, you get a rational number, you get 21.25. Okay, do the same thing for distance 2. Okay, so this time I'm using the top focus. So -9 minus 0 squared plus 6.25 minus 13 squared. So 126.5625, which is 11.25. All right, now subtract. So K is 21.25 minus 11.25. So K is 10. All right. So B is 5. Okay, so I know this distance is 5. I want the dimensions of the rectangle. So I need to know my horizontal distance. I need to know A. Because that's the definition of the hyperbola d1 minus d2. So I need to find A. Okay. I know that B is 5, and I also have C. What is C? 13. So I can use that foci equation, a squared plus b squared equals c squared, to find A. So I'm looking for A, so a squared plus 25 equals 13 squared, which is 169. So I should get A is 12. So that means that my horizontal distance is 12. Now, I'm going to sketch in the rectangle so we can write the dimensions of the rectangle. So the dimensions of the rectangle is like the dimensions of the room. So you want to do length times width. Okay, so if from the center to the top of the rectangle is 5, then that whole length is 10. Okay? And if A is 12, then that whole width is 24. And I use a little time sign to represent by. 10 by 24. Okay. So these definition problems are complex. You have a lot of thinking that you have to do. You kind of have to understand what you're looking for. This chapter is called analytic geometry. So we're not just doing your basic geometry stuff that you did in that class. We're actually really getting in and analyzing these. All right, we have one more thing to talk about, and that's just working backwards. So I'm going to give you some parts, and we want to write the equation of the hyperbola. I use a graph to help me kind of visualize what's going on so then I can write the equation. But you don't actually have to draw the entire graph. We're looking for the equation. Okay. So standard form is your x minus h squared over a squared and y minus k squared over b squared equals 1. And so hyperbola, so one has to be positive, one has to be negative. So I'm going to put a plus or minus and plus or minus. So one of them's positive, one of them's negative. So I am given that I have vertices at negative 4, 0, and 4, 0. So that tells me that this is a horizontal or vertical hyperbola. Horizontal, okay? Those are horizontal, so this is a horizontal hyperbola. So that means that the x will be positive. That also tells me what my center will be. So the center has to be halfway between. So the center is 0, 0. All right. So to write my equation, I need my center, h and k, and I need a and b. Okay, well, I also have a. So a is my horizontal distance. So a is 4. I don't know b yet, and then I have my focus. I have a foci. I have foci at negative 6, 0, and 6, 0. So what does that give me? C. So I don't know b, but I know c, which is 6. So use your foci equation to find b. So 16 plus b squared equals 36. So b squared equals 20. B is the square root of 20. Okay, so you needed B, A, and your center. So So when you write this out, you have x minus 0 squared, which is just x squared, okay, over a squared. So what's a squared? And then minus, so the y has to be negative because it's a horizontal hyperbola. So the x needs to be positive. So that's y minus 0 squared, which is just y squared, over b squared, which is 20, and then equals 1. Okay? All right. So that is where we'll stop. That will wrap up 7-3. Scroll down.